Welcome to the lecture on components of continuous casting unit. So, we will be talking about the different essential details and the components of the continuous casting unit, and we will be talking also about its significance in the continuous casting process. So, as we move on, we will talk about these following components like hot metal handling system, then you have turn disk, mold, water sprays, drive system, and then cut off machine. So, all these system, all these components make one continuous casting unit, and hot metal handling system means it will start from the that system which will be handling that hot metal, it will be bringing that hot metals, that is especially the ladle. Then the ladle, as we know that ladle, from ladle the metal will be transferred to turn disk and then to the mold, and after mold you have the spray zone, water spraying is done, then you have the driving system, and then further in the end you are cutting off. So, you have a cut off machine. So, we will be talking one by one about these systems. Coming to the hot metal handling system. So, as you know that it brings the hot metal and its job is to pour it into the turn disk. So, earlier the lip poured or the stoppered teaming ladles were used. So, that was the practice earlier. But now in most of the cases bottom poured with a slide gate system ladles are used. So, you will have the metal coming from the bottom, and then you will have the slide gate for controlling that flow of the liquid metal. So, you will have a slide gate, and by operating that you can allow the liquid metal to fall from the ladle into the turn disk. Now, small capacity ladles are used for the smaller units, and there will be larger capacity ladles will be there for the multiple strand systems, like when you have the single strand turn disk, then you need the small capacity ladles which will be smaller in sizes. However, if you have the multi strand turn disk, multi strand 6 strand, 4 strand or so, or 8 strand even, in those cases we use the larger capacity ladles. Now, presently what we do is we normally use these dolomite lined ladles to control the dissolved oxygen. So, what has been seen that you may have the lining with dolomite, or you may have the lining with bauxite, you may have even the lining with the silica, and it has been seen that the ppm of the oxygen which is observed in the case of dolomite lined ladles or even the bauxite lined ladles, they are lesser. The observation has been found by Tata Steel. So, it was about 2 to 6 ppm of oxygen was observed in the case of dolomite lined ladles, and then it may go little bit higher when you go with other like silica lined. Then the oxygen level. So, what has been shown, this is a typical it is about 10 to 20 ppm in the case of silica lined ladles. Now, steel will be treated with the calcium for the deoxidation and desulfurization. So, in most of the cases we try to have the minimum amount of oxygen, as well as sulfur is also deleterious for the quality steel. So, we also try to treat with the calcium for the deoxidation and the desulfurization. So, that is what is normally the practice for the in the industries by using the calcium. Common practice to use the ladle furnace for secondary refining. Now, what we have earlier seen that nowadays it is a very common practice to use the ladle furnace. So, that is a very important tool for the secondary refining process, and in that basically you have these ladle with bottom gas purging. So, you will have the purging from the bottom, the gas purging is done, and that acts as the teeming ladle. Now, it is generally lined with carbonaceous magnesia bricks. So, that is the normal practice. Now, when we try to have even the smaller amount of carbon or so, for that, for the decarbonization, many a times we use the VOD process also. And while also using the magnesia brick lining of the ladle, then also we can ensure the low level of carbon, that is what is found to be. So, that is the part so that is the first part. So, because the ladle will be bringing, and then ladle you have the, that can also be used as ladle furnace. So, you will have the ladle which is also lined, you can have the lining with different materials, and earlier the practice was that many type of treatments were done in the Tundis also, but now Tundis will be simply acting as the reservoir. So, normally this this is about the hot metal handling system. Now, we come to the next stage, that is your Tundis. Now, in the Tundis, as you see that Tundis will be that vessel which will be after that ladle. So, the Tundis will be receiving the liquid metal from the ladle, and then it will be distributing it, or it will be passing that liquid metal to the mold. So, as you see that the Tundis will be necessary to team the steel from the ladle to the mold. It acts as a buffer vessel between mold and the ladle. Buffer vessel, as we have already discussed, that that will be the vessel which will be supplying the liquid metal whenever, even in the case of ladle changeover. So, one ladle when gets emptied, then when that ladle is removed, and then next ladle comes to supply the liquid metal to the Tundis. So, in that situation, even the continuity of the liquid steel from the Tundis to the mold is maintained. So, that is why it is known as a buffer vessel between the mold and the ladle. Now, it maintains the casting continuity. So, as we have already discussed that even if there is no ladle, it will go on having the, there will be continuity in getting the liquid supplied from Tundis to the mold. So, the casting continuity will be maintained. It improves the yield, because from there it is going directly to the mold, and you are getting the finished product. So, that way many a times now in most of the cases what we normally do is we try to preheat the Tundis, because the Tundis which is there at room temperature, and if you are initially supplying the liquid metal to the Tundis, then there may be temperature drop in the liquid steel, and that may affect the quality of the steel. So, in most of the cases you are preheating, so that the heat loss which will normally take place, that will be minimized in those cases. Then the Tundis will control the steel flow more accurately, because you have the control mechanism, and you are basically you are controlling that, so that the constant amount of liquid steel should fall into the ladle. So, also because it has a very large surface area, and in that case normally during the changeover also there will be very small decrease in the height of the free surface of liquid metal in the TUNDIS. So, the change in the velocity will be very small. So, basically the steel flow will be controlled more accurately because of the TUNDIS. Now, this TUNDIS also will be subdividing the flow into several streams. So, what happens that when the liquid metal will be going. So, when as you see that in the case of so you have initially you have the ladle, and then you will have a TUNDIS. So, this will be your TUNDIS in fact, and in the TUNDIS this is, so this will be so there will be entry of liquid metal from the ladle into the TUNDIS, and then you have these are the outlets. So, these are the exit ports of the TUNDIS. Now, in normal case you have this is how one stopper rod is also there. So, this is known as a stopper rod. So, this stopper rod basically, as we are discussing, that this will be controlling. So, you can put the stopper rod in this zone. So, that will regulate the flow of the liquid steel to the mold. So, here from it is going to the mold, it is going to the mold here. So, basically you have this way it controls that the quality quantity of metal which will be flowing into the mold. Now, coming to talk about the dividing the flow into several streams. So, what happens that when the flow will be coming here and when it will be striking. So, metal will be going from here like this, and it will be going like this from here. So, this way it will be moving to in the different streams, the metal will be going. Now, you may have 2 strand, you may have 4 strand or 6 strand. So, this metal is divided into different streams in different directions depending upon the even the configuration of the TUNDIS also. If you have a TUNDIS, suppose you have a TUNDIS and you have the inlet here only, and your outlet is only here. In that case, anyway liquid metal will hit here, and then it has to move in this case. So, there will be some movement this side also, but otherwise if you are hitting in the middle portion, in that case it will be divided into different streams, and then it will be moving towards the different outlets on the on both the sides of the inlet stream, where it is striking the TUNDIS bottom. So, so that is the job of the TUNDIS also, that it will be dividing that stream. Now, it will be deflecting the metal streams as the same thing, because once it will come and then it is going towards the wall, and because of the wall of the TUNDIS it will be deflecting from there and it will move towards the outlet. The ultimate aim is that in an optimal manner with a proper flow configuration, the metal which is entering into the TUNDIS, it has to move towards the outlet. Single large mold can be teamed with number of streams. So, that is possible, because you may have different streams, and by that if you have a large mold, then it can be teamed with the number of streams. Metal level in the TUNDIS can be altered, because it is altered in the case of lateral changeover normally, and since that the level whenever many a times our job is also to in earlier times when we are talking about initial days, when you have to cast different grades and you have only one TUNDIS. So, in those cases you have to decrease the level of the material in the tundish, and then further you have to start filling it. So that way you can do that in the tundish. So it will go to certain lesser height, and then further you will start filling it with the ladle. So then next grade will be started filling. Then you have also the possibility of the cleaning of steel in the tundish. So many in the past also it has been seen that there are sometimes the cleaning operation is also done in the tundish. You have and even now because we think of having the tundish to act in such a manner that if there are any inclusions, they must float. So the inclusions must be removed from the steel in the tundish. So it also works as the reservoir which will be looking towards minimizing the inclusion content in the steel. So that we will see later. Now it will also help in removing the slag, because slag, if there are, so they will be floating at the top. So if the slags are entrained, so because of the flow, quiescent flow inside which can be maintained, you can allow these slags also to, normally in normal circumstances the slag will be at the top, and so beneath that there will be molten liquid. So that way it will be we also have the get the help in removing the slag also. So because it will be at the top portion, and we are taking the liquid so slag will be towards this top portion, and liquid metal is steamed from here. So it will be delivered to the mold from here. So anyway, that slag does not cause any harm, and it will be delivered to the mold. So then the metal comes towards the mold. Now we all have already discussed that this mold is made of the drawn copper tube or machined out of a solid block, or is a welded plate construction of high conductivity electrolytic grade copper. So the mold in the case of continuous casting is made with the high grade electrolytic grade copper, and copper is chosen for the obvious reason that it has very high conductivity, and it can remove the heat of the molten metal very fast. So but then as we discussed that since the melting temperature of copper is small, smaller as compared to, or less as compared to that of steel, so we need to have the other cooling mechanism constantly, so that it can take the heat away quickly, and it should not melt also, and for that it is normally water cooled and has open bottom and hence closed by a dummy plug bar in the beginning. So initially in the beginning we close it with a dummy plug bar, and then normally it will be have open bottom, and then water will be coming and flowing, and during that process that water will be absorbing the heat which will be released by the liquid metal in the mold, and then it will be that, so the water takes the heat, and then that is why you will have the change in the temperature of the incoming water and the outgoing water, because that water will be taking that heat which is being released by the mold. Length of the mold depends on the cooling conditions that formed adequate skin before ingot emerges out of it. So this is very important, that what should be the length of the mold, and that will be depending upon the cooling conditions. The cooling conditions has to be such that the adequate skin is formed before the ingot emerges out of it. So as we have seen that in the case of mold, when the liquid metal will be poured through it, so it will be started forming the skin, and this skin thickness, the cell thickness will go on increasing on both the sides. Now, the thing is that when your what should be the height of this mold. So, it has to have at such a place, so that to ensure that there is a skin freeze of certain thickness, and then because it has to further come, and then it has to move on the rollers, and further it has to move and finally it has to be in horizontal direction. So, there is large amount of pressure of the liquid steel, ferrostatic pressure is there. So, you ensure that cooling, so that a skin of adequate thickness is developed at the end of the mold. So, that has to be ensured. So, that is what it will be the requirement in the case of mold. Also, it will be avoiding the transverse cracking, it is oscillated at the rate of 30 to 60 oscillations per minute. So, what is happening, we have already seen that you are giving that oscillation for certain regions, you are giving the negative strip. So, it has to leave that mold, and then so that oscillation, and also in the mold we are giving the lubrication. So, if you talk about the function of the mold, it is to obtain the enough cell thickness of solidified cell to stand bending stresses and ferrostatic pressure of liquid steel from inside. So, what we see nowadays, we have seen that also your mold is from there itself, it is somewhat curved. So, you will have the bending stresses, and also you have the ferrostatic pressure of the liquid steel. So, the the cell thickness which should be achieved at the exit point of the mold, that is your primary cooling zone, it must be adequate to bear to stand the bending stresses as well as the ferrostatic pressure of the liquid from inside. Then its also job is to equalize the temperature all through the liquid steel mass. So, it must ensure that there is a proper temperature, otherwise there may be different structures on different sides, and that also ensures internal surface quality of the product, because there are likely to have the generation of cracks or other kind of defects because of the improper cooling conditions in the mold. So, there also it is ensured. So, you have earlier vertical molds, then we get nowadays the curved molds, which are complicated, and modern molds are tapered to narrow down towards the bottom, and it is basically to account for the shrinkage, because when we know that there is tapering which is done because the metal which is getting solidified and it has higher density. So, there will be shrinking of the metal, and to account for that, there is some taper which is given in the mold to account for that. So, that is another sincere calculation which needs to be done to avoid any kind of defect in the case of continuous casting. They are invariably, mold is also invariably lubricated to assist the stripping. So, as we have discussed that there will be some lubricating mechanism which should be there in between the mold wall and the liquid metal which that will get solidified in the skin, so that there should not be sticking, and then there is proper stripping of that product from the mold. So, that also is ensured by having the choice of proper mold lubricants. Next comes in the line will be the submerged entry nozzle. Now, the submerged entry nozzle is the ceramic tube which has a closed bottom, and is connected to the tundis at one end, while the other end is dipped in the molten pool in the concast mold. So, that is basically if you talk about this tundis. So, from here this will go and this will be submerged entry nozzle, and then it will go into the mold, and here it is closed and you have opening on these sides. So, this way you have this is your submerged entry nozzle. So, in the slab casting, this SCN has two openings in the opposite direction, and in blooms it may have 4 openings to distribute the steel uniformly. So, it may have depending upon what you are casting, you may have either 2 openings or 4 openings to distribute in the steel, because from there it will come. So, normally when you if you look at the liquid, so it will go and then it moves like this. It will strike here, some will go up and then some will go down. So, like that liquid metal will come, and so you will have a loop also formed here in many cases. So, that is because of the submerged entry nozzle which is there, which is closed from one end, and another end will be from the tundis it will be coming down. So, it is on the one end on tundis, another is in the mold. Now, coming to the submerged entry nozzle, argon gas is used to prevent sticking of steel to the SCN surface and aspiration of air through the tube pores and joints. So, that is normally the practice, that you are using this argon gas, so that the SCN surface is not stuck to the steel, and also there is no aspiration of air. Mainly Al2O3 and C is used as the base material for making the SCN, and also you may have the zirconium oxide, carbon is also in many cases it is used. The main problem of using the SCN is that it gets clogged due to the accumulation of alumina from inside. So, many times the alumina which is coming because of that there may be clogging in the SCN, and that will be leading to decrease in the flow rate, causing problems in solidification of steel in the concast mold. So, that is really a challenge, because if there is clogging, then there will be decrease in the flow rate of the steel which is coming through that SCN ports. So, that is another challenge, and that is because of the inclusions or the alumina which is accumulated. Mold lubrication. So, mold lubrication is earlier you had the moisture free rapeseed oil was used as the mold lubrication, as we had discussed that you have to have something lubrication so that there is no sticking. Now, we have mold fluxes are used to have the smooth casting operation, and it will be added as the powder in the mold over the liquid steel surface. So, that is the normal practice. You have a powder which will be given at the surface, and when it will be coming in contact with the liquid surface, it will be melted, and then it will be going in between the mold wall, and so there will be a layer of that lubricant, and that will allow that will ensure that there is no sticking of the surface. And also the another advantage is that it will be preventing the oxidation to take place from atmospheric air. So, this is the example of these mold flux powders. Then the function of these mold flux are that there will be lubrication of the stand, then you have transfer heat from stand to the mold wall, and then thermally insulate the top steel surface, that is what we have discussed, protecting the surface from atmospheric oxidation, and many a times it will be absorbing the inclusions, because inclusion if they go up, so that powder they will be attracting those inclusions. So, that is another advantage of these mold lubrication mechanism, and they are in different forms. We use it like fly ash based powder, synthetic mixture, pre-fused and ground flour powders, and then granulated powders also. So, that way we give this mold lubrication. After that you have the secondary cooling of the solid product, and it will be accomplished by quenching using high pressure water sprays. So, we are using those water sprays, and then the cooling is done. So, 90% of total heat is to be extracted in that secondary cooling zone after the mold that zone starts, and spray design in the curved mold is far too critical because the ingot has to be bent continuously. So, there also it is bending. So, it is another challenge there that it is bending. So, you will have less area here, more area. So, properly you have to have the cooling, so that the uniform structure and uniform properties are to be ascertained, and then finally it will go, and then ultimately we are cutting it once we ensure that it is completely solidified. So, you will have a cutting torch and that will be cutting it. So, these are basically the the components of the continuous casting units, and you can study more from the reference and textbooks to have more understanding, which will help us to discuss more on the issues in our coming lectures. Thank you very much.